In this video, we're going to look at finding the complex solution. So that's both the real solutions as well as the imaginary solutions. So I'm going to use the DESMOS graphing calculator to get our real solutions first. So let's take a look. You'll notice that I've typed the equation here into the DESMOS graphing calculator. Now, if you're not familiar with the DESMOS graphing calculator, I'll be sure to link it below. That way you can use it. You'll want to bookmark it because it's definitely a nice resource. It's completely free and has all these great graphing features. I'm going to zoom out just a little bit, making sure that that is in fact our only real solution. Notice I'm looking at the x-axis. That's where we find solutions. At this point, when I hover over it in Desmos, it gives it to me as a coordinate point. However, we know only the x value is what we're looking at. So I know that I have a solution at x equals 2, and that is our only real solution. So let's go back to the equation and find the imaginary ones. All right, now that we have the real solution at x equals 2, we're going to use that to find the other two solutions. And the way we do that is through synthetic division. So I'm going to put that 2 here on the left. Then I'm going to use the coefficients of each of the terms. So I've got 1, -8, 25, and -26. So let's review a little synthetic division here. We bring down the 1. 2 times 1 gives me 2. And now we add. That gives me -6. 2 times -6 gives me -12. That gives me 13. 2 times 13 gives me 26. And now I get 0. I should get 0 here because 2 is a solution. And this 0 here is the remainder, which if we have a solution there, we should get a remainder of 0. But I'm not interested in that. I'm interested in these other 3 terms. So let's take a look at putting the variables back in. I see that the highest exponent in the original equation was x to the third. I'm going to decrease that by 1. So now I have 1x to the second minus 6x plus 13 equals 0. Now I have a quadratic that I can solve using the quadratic formula. I notice that a is 1, b is -6, and c is 13. So let's put that in the quadratic formula. Negative b would be +6 plus or minus the square root of b squared, which would be 36 here, minus 4 times a times c, all divided by 2 times a. So I've got x equals 6 plus or minus, I've got 36 minus 52. That's going to give me a -16. And I know you're thinking, oh no, a negative underneath the square root, but that's okay. Remember, we're anticipating to get complex solutions with imaginary numbers. So we know the square root of 16 is 4, and then we'll deal with that square root of -1 by putting an I here. Looks like I can divide each of those by 2. So I've got 3 plus or minus this 2i. So my solutions, the real one is 2. The non-real would be 3 plus 2i, and the other would be 3 minus 2i. So we've got our 3 solutions. We knew that because of the highest exponent of 3, and we have 1 that's real, and we have 2 that are not real.